Well, good evening, everyone. It's great to see you all here virtually. I'm Matthew. I'm the observatory manager here at the South Carolina State Museum. And tonight on our telescope live stream, we're exploring the constellation Orion. So we're going to be looking at one of the stars in Orion. We're also going to have a look at the Orion Nebula. And we're going to have lots of fun exploring this very, very well-known winter constellation. So now, if you've never joined us before, feel free to ask questions in the chat or put greetings in the chat. I see Anita has said hi. Hi, Anita. Good to see you as always. So if you have questions, feel free to pop those in the Facebook or YouTube chats, and we'll answer them on the air for you. And otherwise, we'll enjoy these really cool views from the telescope. So just to get us started, right now we are looking at the star Betelgeuse. This is the one of the bright stars in the constellation Orion. And one of the things about this star that you might be able to see just a little bit here, I think it could be a little tough. To me, the star does kind of look white. But if you look closely, especially if you're watching on a computer, this will be harder to see on a phone. If you look closely, you might notice that there's this slightest tint of orange or to the star. So Betelgeuse is actually a red star, and red stars are cooler. So blue stars are hot, red stars are cool. Betelgeuse is a red star. It's called a red supergiant. It's a big red star, much larger and brighter than the sun, but also much cooler, and also at the end of its life. So the thing that's kind of interesting about Betelgeuse is that this star is probably one of the most likely stars in our sky to go supernova in the relatively near future. Now, relatively near future does not mean within the next few years. It means within the next 100,000 years. So I think it'd be really awesome if Betelgeuse went supernova during my lifetime, because it would be by far the brightest thing in the sky, be bright enough to see in the daytime. But chances of that happening, not so good. It could go off anytime in the next 100 years or 100,000 years. So, yeah, it'd be really fun if that would happen, but don't hold your breath. One thing you might notice is the star looks like it's kind of bubbling around, sort of shaking around, maybe dancing around. The image isn't completely steady. Now, I was just talking about how Betelgeuse is at the end of its life. Now, this sort of motion you're seeing is not because Betelgeuse is struggling and all that kind of stuff. It's because we're actually looking at Betelgeuse through Earth's atmosphere. So all that motion you're seeing in the star, that's actually caused by the atmosphere of the Earth. So that's why you're seeing Betelgeuse moving around there. Betelgeuse was actually in the news a few years ago. It was actually back in 2019 and early 2020. It's right before something called COVID came and took over our lives. Betelgeuse actually appeared to get fainter. It dimmed quite a bit, noticeably. It actually looked noticeably dimmer in the night sky. And this was potentially because Betelgeuse actually belched out a bunch of dust or something like that. And the dust actually blocked some of the light from the star and made it look fainter. So that was a really kind of interesting thing that happened with Betelgeuse that reminded us that this is not a stable star. This star is approaching the end of its life, and it's kind of, it does really kind of weird things as that happens. So again, if you have questions, feel free to pop those questions in the chat. We can just hang out and enjoy the view of the star here. And if you have questions, just pop those in the chat. We'll get those answered for you. Looks like I need to recycle the camera because it's about to time out. Just a second here. Taking a moment here for camera control. There we go. So we're using our big Nikon camera on our big Alvin Clark telescope right now, and the camera's in live view, so this is actually a live video feed. But when the camera's in live view, the shutter will time out. And so every about 10, 15 minutes or so, we have to reset the shutter. So that little countdown you saw, that was the shutter about to time out, and then I just reset everything. So we can continue to hang out here and see Betelgeuse. So let's poll the audience. Betelgeuse is probably also the closest star to us that would go supernova. How many of you all does that make nervous? So if that makes you nervous, oh my gosh, Betelgeuse is going to go supernova and causes problems here on the Earth. Post in the chat. Do you think when Betelgeuse goes supernova, it's going to cause a problem for us on the Earth or not? What do you think? Let's see, Anita asked, do you know the age? I actually can't remember the age of Betelgeuse off the top of my head, so I am going to pop up on my phone here, and let's look that up. Just a second here. Betelgeuse is about 10 million years old. Now, here's the thing. Our sun is about 5 billion years old. So I see some no's coming in. Yep, Betelgeuse is about 600 light years away or so. So it's nowhere close enough to us to cause us any problems when it goes supernova. It will, however, give us a rather spectacular light show because it will become the brightest thing in the sky. So Betelgeuse is about 10 million years old. Our sun is about 5 billion years old. That's billion with a B. So larger stars actually don't live as long. So Betelgeuse is a larger star, and earlier in its history, it was a much hotter star than the sun. And these stars basically burn up their hydrogen fuel much, much faster than a smaller star like our sun. So these large stars just go through their hydrogen in their core, and then they don't live that long. So that's actually kind of an interesting thing. Really small stars, really dim stars, they tend to last quite a bit longer, or much, much longer than these very large stars. So again, Betelgeuse, 10 million years old versus our sun, 5 billion years old, and our sun has 5 billion years left. So it just really gives you a sense of how much faster these large stars use up their nuclear fuel. I'm noticing the star is fading just a little bit, and that makes me think I might need to go check the dome and rotate it. So I'm going to pop off camera here and go rotate the dome, because I think Betelgeuse might be about to get blocked by the dome. So give me just a second. I'll be right back. I'm back. Dome rotated. David says, all I see is a white dot. Yep, that's the star Betelgeuse. And in our camera, it's looking a little bit more whitish than it is reddish. And then Walter asks, when it goes supernova, what happens to the planets around it? So as best we know, Betelgeuse does not have any planets around it. It seems like the stars that are more likely to have planets are smaller ones like our sun. And part of this is that it takes a long time to form planets. And in the lifetime of a star like Betelgeuse, only 10, 15 million years, that's actually not enough time for planets to form. around the star. And the other thing about these giant stars is they tend to have really intense, what we call stellar winds. So they tend to emit lots of energy and particles and all of that, which blasts the space out around them. So these are not great stars for you to get like the uh, what we call circumstellar disks. Trying to search for the word there. They're not stars that are really conducive to having these disks of material around them left over from when the star formed, because that's actually what the planets form out of. They actually literally shove that away. So these are generally not your so great places to find stars. So once again, if you do have questions, feel free to pop those in the chat, and I'm happy to answer them. Otherwise, we can just hang out here and enjoy this view of Betelgeuse. At about 8 p.m., we're going to take a break and move the telescope over to the Orion Nebula. That might take a few minutes, so there'll be a few minutes while we reset everything and then have a look at the Orion Nebula. We actually got a really great view of the Orion Nebula the last live stream back earlier this month, and we like the Orion Nebula so much that we're going to have another look at it. It's just a really amazing object in the wintertime sky. And how long does it take for that light to get to Earth? So Betelgeuse is about 600 light years away, roughly. That means that the light from Betelgeuse takes about 600 years to get to us. So really, that's kind of one of the neat things about the fact that we use light years as a measure of distance, is that that distance in light years also gives you a sense of how long it took the light to get to us, because a light year is the distance that light travels in 1 year. So if we're looking at something that's a million light years away, we're actually looking a million years back in time. So you can think of a telescope as kind of a cross between a spaceship and a time machine. And I think that's one of the coolest aspects of telescopes, is that sort of spaceship time machine hybrid that they are. So one of us, as David said, that yeah, Betelgeuse looks like just a white dot. So again, a lot of that's the camera that we're using. Um, if you go outside and look at Orion, Orion is nice and high up in the south right now. Betelgeuse is actually the star in the upper left corner of Orion. And if you go out and look at Betelgeuse with just your eyes, you will notice that it does have a sort of orangish tint to it. So it's actually the color of Betelgeuse is something you can see with just your eyes. There goes our shutter again. I'm going to go into my little recycle so you'll see their view disappear for just a second while I cycle this out. There we go. We'll restart. Fun of working with astronomy cameras. Let me get back to where I can see you all, or at least your comments. So we've been having some fun talking about Betelgeuse and supernovae. We have seen supernovae in our galaxy before, but it's been a very long time. It's been several hundred years. So we're actually kind of overdue for a supernova in our part of the galaxy. And Betelgeuse is definitely one of the more likely candidates for that, but it's we're overdue for that. The last time there was a supernova anywhere near us was back in the year 1987. There was a supernova in the Large Magellanic Cloud, which is actually a satellite galaxy of the Milky Way. We can't see the Large Magellanic Cloud and the Small Magellanic Cloud from Columbia. You actually have to be in the southern hemisphere to see those. So our friends in places like Australia and Argentina and Chile get beautiful views of the Large and Small Magellanic Clouds. So this supernova went off in the Large Magellanic Cloud in 1987, and it gave us a really nice up-close view of a supernova happening. Um, the Large Magellanic Cloud is somewhere, I can't remember the exact number, but it's somewhere like around 170,000 light years away. So when Betelgeuse blows, it'll be a lot closer to us, but still not close enough to cause us any trouble. Now, astronomers actually see supernovae in distant galaxies all the time. In fact, there actually are some telescopes that their job is to actually scan from galaxy to galaxy in the night sky to see if a supernova's gone off in a galaxy. And that's actually not uncommon to sweep by a galaxy and discover, yep, star blew up in this galaxy. And when that happens, star looks like, or the supernova looks like this sort of bright spot inside the galaxy, which is wild because basically a supernova releases so much energy that in its earlier stages, it can actually outshine an entire galaxy. That's how powerful they are. So, question for the audience. Do you think the sun is going to go supernova in 5 billion years? When the sun comes to the end of its life? Way in the future. Wouldn't worry about it. But do you think the sun is going to go supernova in 5 billion years? So we have Lisa. Keith said no, it doesn't have enough mass. Okay. Got one idea there. Let's see if anyone else has something to say about whether the sun would go supernova. So, right, Lisa, the sun actually does not have enough mass. It's not a massive or large enough star to go supernova. When the sun comes to the end of its life, it's actually going to poof its outer atmosphere up and swell up really, really big, and then it's going to puff that outer atmosphere off into space. So it's a much less violent end. You really have to be around, I think it's somewhere like around 8 to 10 times the mass of the sun, at least. Probably around 10 times the mass of the sun to go supernova. So supernovae are really only things that the very largest stars do. And once again, in just a few minutes, we are going to move the telescope over to the Orion Nebula and see how that looks tonight, see how that really beautiful star forming region looks. And that'll take us just a minute or so to set up. Uh, so we're going to get moving the telescope in just a minute. I will have to take a break and go off camera to do that as we move the telescope and reset the camera. But that's what's coming up. We're going to have a look at that very famous star forming region again. We had a look at it last live stream. I just don't think you can get enough of it. It is such a cool thing to look at and so beautiful. So that's what's going to come in just a few minutes. Probably in about 2 to 3 minutes, I'm going to go off camera and pop in the observatory and go ahead and get our telescope moved to the Orion Nebula. All right, well, I'm going to go ahead and get the telescope set up for the Orion Nebula. You're actually going to see me come back in here in a moment because I'm actually going to have to move the telescope. But we're going to go ahead and start this process. So here we go. I'm actually going to turn off our screen share there. I've got to go do some weird things on that computer to get it set up. So here we go to the Orion Nebula. All right, so I'm about to start the telescope moving here. It's actually going to take, or actually rather, it's not going to take that long, but I'm actually going to need to go and dash really fast into the observatory just to watch the telescope after we start it moving to make sure it doesn't, usually it moves where you want it to, but sometimes it has a glitch and doesn't. So we're going to want to just really monitor that closely. So I'm going to, as soon as I start the telescope moving, I'm going to be going in there to watch it. So here we go. right. Well, Captain Matthew is back. We have just flown the telescope to the Orion Nebula, and we have successfully found it. So I'm going to get us set up to actually take a picture of the Orion Nebula. Are we ready for this? This is going to be kind of fun. Gonna see what the Orion Nebula looks like. Let me actually get all the screen share working again here. So you can actually see our camera controls. That's where we're headed with this. So here we go. There we go. So you're seeing actually our desktop for the computer that's actually over in the observatory running the camera. And what we're going to do is we're going to take a picture of the Orion Nebula. So we've got everything set up. It's actually the window there in the middle is our camera control window. So I'm going to go ahead and fire off a picture. We are going to take about a 10-second exposure. So the camera shutter is going to stay open about 10 seconds before we actually see anything. So here we go. I'm actually going to change the ISO number just a bit, make the camera a little more sensitive. All right, here we go. So now the shutter is going to stay open for 10 seconds. And then when it does, or when it closes, we should see the image pop up here in this folder I have open. There it is. Let's have a look and make this big. See what we got. All right, I want to make this really big. So let me get it where I can see you all again. Always lots of windows open with these things. So there we go. There's the Orion Nebula right there. So this is a giant cloud of gas where stars are forming. So with Betelgeuse, we were talking about stars at the ends of their lives and stars going supernova. So one of the cool things about the constellation Orion is we can see all of these different stages of what we call stellar evolution in that one constellation. So we have Betelgeuse in the constellation Orion, which is a super old, or a star that's near the end of its life. It's not really an old star because large stars don't live that long anyway. And then we have some really bright, hot white stars in the constellation Orion. These would be stars rather like the stars in the belt. That those are relatively young. And then we have areas like the Orion Nebula, which are places where stars are actually forming. So deep down in this cloud of gas are where stars are being born. It's like a star nursery. Now you'll also see that there's some stars that are actually in the nebula that are super, super bright. Those are actually stars that formed in the nebula, but they have now completed the process of forming and they are now actually turned on. So nuclear fusion has started and they're actually these really, really hot, bright, young stars inside the nebula. And it's actually those stars that cause the gas to glow. So all that energy and radiation from these really hot young stars actually causes the gas in the nebula. It's mostly hydrogen gas. It causes the gas to ionize. And when the gas ionizes, it starts to glow. So you're actually seeing glowing hydrogen gas right here that's been lit up by those young stars inside the nebula. Pretty cool. So once again, if you have questions, feel free to pop those in the Facebook or YouTube comments and we will get them answered for you. And what we'll do is in a few minutes, we'll take another picture of the nebula and then we'll change something about the camera settings. So do you want to see what the Orion Nebula looks like with a different camera setting? Yeah? Let's do it. So, where in the sky is Orion currently visible? Right now, if you go outside and look directly south, you will see Orion. It's very large up in the south, very high. It's actually quite high up right now. So that's where to go look for it. So let's go ahead and have another view here. We're going to close this guy out, get my camera controls. So again, we looked at the Orion Nebula back earlier this month on the same live stream, but one of the things we didn't do was see what happens if we take a really short exposure. So last time we actually took, I believe it was 5-second, 10-second, and 15-second exposures. So we're going to try taking a 1-second exposure here. So we're actually going to leave the shutter of the camera open for only a second, and we're going to see what we get. All right, let's have a look at this. See what a short exposure looks like. So here's our 1-second exposure. What do you notice? What do you see that's different about the 1-second exposure of the Orion Nebula versus the 10-second exposure we showed a few minutes ago? So Anita says doesn't look cloudy. Okay, less visible gas. So yes, when we took a shorter exposure, we don't see nearly as much of that glowing gas. So we can see those stars inside the nebula. They're the brightest things there. The gas around those stars is actually quite a bit dimmer. So when we take this 1-second exposure, we only see a little tiny bit of the gas around the stars. Can you see that there's still a little bit of gas visible, like close to the stars? Sort of looks like it's in the background. Pop a note in the comments if you can see a little bit of that gas still there. Christina can see it. Yep, it's sort of there. If you're watching on your phone, it may be harder to see the gas. Yeah, so we're just seeing a little bit of the gas around or excuse me, it just is really super close to those stars. That's kind of the brightest gas in the nebula. So yeah, definitely not so much to see. So when we take longer exposures with the camera, what we're doing is we're leaving the shutter open longer, and that is actually allowing light time to build up on the camera detector. So what do you think would happen if we took a 30-second exposure of the Orion Nebula? What do you think we'd see? Make a prediction and pop it in the chat. And then we'll actually take the picture and find out. So what do you think we'll see when we take a 30-second exposure of the Orion Nebula? Debbie says more gas, more stars. Okay. I need other ideas? Well, let's find out. So once again, this means that we're going to be holding the shutter of the camera open for a full 30 seconds, which means there's going to be a bit of a delay until we actually see the picture. So that's always kind of one of the fun parts of taking astronomy pictures is when we take these timed exposures, there's the waiting for the exposure to come in. So here we go. We're going to click the shutter speed all the way up to 30 seconds here. To click it a bunch of times. For some reason, it seems like our controls are being a little slow. I'm not sure what that's about. Here we go. Now we're starting to move. Okay, let's take our 30-second exposure and let's see what we get. Here we go. Just open the shutter. Now we get to sing our favorite song for 30 seconds. Or make weird faces for 30 seconds. By the way, those are things that astronomers actually do when they're at a telescope, say late at night. At a place like Kitt Peak Observatory in Arizona, is when they're waiting for their exposures to come in while they're at the telescope late at night, they might make weird faces at each other or sing fun songs, anything to keep them awake. Okay, well, it looks like something has come in here. Let's see, it looks a little weird. Well, what I'm noticing is that we're only seeing a part of the nebula. I'm wondering if something happened with the telescope. Let me just do some checks here. That was actually not what I was expecting. So it's like, ooh, weird stuff happened. So let's see if we can figure out what happened there. We might have gotten a tracking error. Let's see here. Either that or the dome got in the way. Let me go have a look and see what's going on here. The telescope doesn't seem to be giving us the view of the Orion Nebula I thought it would. So time to go do some troubleshooting. My favorite part of working with telescopes. So here I go. Well, that was a whole lot of fun. The telescope actually lost the Orion Nebula. And then let me show you what it did. I found the Orion Nebula again, but let me show you the test picture I just took. So this is an example of when things don't quite go right with the telescope. What do you see going on here? So this is the gas cloud right there in the middle, but what do the stars look like? So what do those stars look like? Do you see those streaks of light in the image? Blurred. Yep. So what's going on here is the telescope happens to be hanging out at a spot where it doesn't track very well. And for some reason, there's some bug in our system. And where the telescope is pointed right now, it doesn't track perfectly. Now, in about 10 minutes, right after we're done with the live stream, of course, the tracking will settle down and we'll be able to take nice, steady images again. But for right now, the telescope is hanging out in that little zone where it just isn't happy tracking. It's never been happy tracking there. It's always like, I don't want to track. And because it's not tracking properly, we're actually seeing the images appear to, or the stars appear to move through the image. So remember, we're taking this is actually a 5-second exposure here. I ramped that way down from 30 seconds. So over the course of that 5 seconds, the telescope wasn't tracking properly. And so the stars and actually the gas cloud appears to move. And that's why you get those streaks right there. So I don't think we're going to be able to get the 30-second image. But actually, I'll just tell you that with a 30-second image, we don't necessarily see more stars and more gas. So it turns out that from our location, we're actually operating and viewing here from downtown Columbia. And in downtown Columbia, there's a lot of light pollution. So when we take longer exposures with this camera, instead of seeing more stars and gas, what we'll often start to see is the background glow in the sky of the lights of Columbia. And it often looks kind of like this weird pinkish orangish color. If we were under a very, very dark sky, say in the middle of the desert, we actually could take a 30-second exposure and we wouldn't get that background. But when we take a longer exposure here under our city sky, we actually start to see all those city lights in our images. So really, there's sort of this point of a law of diminishing returns with this camera that we're using tonight and exposures. I find that we can typically push this camera up to about 15 to 20 seconds before we really start to see that light pollution and the images actually start to go down in quality. So it's like these 15-second exposures we've taken are sort of at the max of what we can do successfully. So since we got a picture of the Orion Nebula with the telescope not working quite right, which is what telescopes love to do, um, it's like every telescope has some kind of quirk. I'm actually going to get us back to one of our earlier pictures that we took this evening, just so you can once again see the nebula in all its glory. So we have just a few minutes left, so we can take some time just to gawk at that beautiful Orion Nebula from pictures we took a little earlier. So let's just enjoy the image. I'm going to be quiet, so just so you can enjoy the view. And if you have any questions over the next few minutes, just feel free to pop those in the chat and we'll get them answered. But otherwise, I'm going to be a little quiet so you can just enjoy this beautiful view of the Orion Nebula. So, Nita, I'm curious, what is Dooley? Is that an observatory in your community? Ah, yeah, that's right. Just reminding myself that at Francis Marion University, we have the Dooley Planetarium. Yes, well, good friend Jeanette Myers, who is the director of that facility over in Florence. Yep, Francis Marion. Yeah, that's a really neat, smaller planetarium. Actually, very similar in a lot of ways to our planetarium here at the State Museum. It's just in a smaller dome. So we do have one of these live streams coming up again on March 5th, Saturday, March 5th, 7:30 to 8:30. That's actually going to be our last live stream for a while. And the reason why, there are actually a couple of reasons why. First of all, we're about to hit the switch back onto daylight saving time. And when we do that, we end up getting these live streams much later. We have to schedule them instead of 7:30 to 8:30, we have to schedule them at like 9 to 10 p.m. And we're kind of a small staff right now at the museum, trying to get a whole bunch of different things happening. So we really don't have the staff time to put to having live streams as late as that. And also, it's not such a great situation unless you really want to stay up late for our audiences, especially for our families with kids. The other reason is we are going to be starting to filter back some in person night viewing opportunities here. And the first public one coming up is on May 15th. So, May 15th, there is going to be a total lunar eclipse visible from Columbia and actually South Carolina and really the country. And we are going to be open that night to see that total lunar eclipse. We'll be open from 10 p.m. to 1 a.m. So 10 p.m. on the night of May 15th to 1 p.m. Excuse me, 10 p.m. Let me make sure I get all the PMs and AMs right. 10 p.m. on the night of May 15th to 1 a.m. early in the morning, May 16th. So it's sort of an overnight through the midnight hour event because it is a late night eclipse. So we will be open for that. Hopefully, we'll have clear weather and we hope to see you there. So, yeah, we're going to start seeing these um, in person opportunities coming back. Probably not on Tuesday nights as we were doing before COVID. It's going to be a different model and a different day of the week, and probably not quite as frequent just because of our staffing situation. Um, that is something that we are looking to get started again, though. During the public events, will you also have anything online for those who can't be there? That's a great question. I am not sure that we will be able to, and the reason why is when are doing a public event, we have to focus all our resources on the people in the observatory because there are things like cables and such from cameras. We'll still be using cameras, I think, for the eclipse event because of the COVID situation. And because of that, we have to have our staff monitoring the telescope and our guests to make sure everyone stays safe and doesn't trip over a cable or something like that. So, running a live stream and a public event at the same time is a little bit challenging. We'll see if there's a way to do that, but I'm not sure that we can just because we have to really focus on the people who are actually coming through the door here and making sure they have a good experience and also stay safe in our dark observatory with camera cables and all of that hanging around. Well, I'm going to go ahead and call it a night. It's been wonderful hanging out with you all this evening. Thanks for all the questions and for participating and for hanging out and watching us when we had the telescope do funny things like not track properly and all of that. It's always kind of fun to troubleshoot a telescope. It's very, very typical experience when working with a telescope, especially when you're doing this type of taking pictures. So it's been great to see everybody. I'm going to go ahead and say good night. So see everyone later. Stay safe and well out there. And we'll talk to you soon. Bye now.